What's up, Alge 1A? So we solved systems by graphing last time around. The problem with graphing is it does have its limitations. Some of those limitations, for example, are what if the lines do not cross at a perfect grid line? What if they're between grid lines? Are we to just guess, or what are we to do? What if the lines intersect off our graph? How do we figure out where that is? Well, other than making a large graph or going through a whole big ordeal, we have other ways to solve systems. So the next way that we're going to learn to solve systems is by substitution. And solving by substitution is exactly that. We are going to substitute value from one equation into another. For some reason, this seems to be the one sticking point for a lot of students when it comes to Unit 13. So we're going to take it slow, show you some examples, and we'll provide more as necessary. So we'll start with the system that we are going to solve, and that system is going to be y equals x plus 1 and y equals 2x minus 5. Now, we could go ahead and graph these and find their point of intersection, but like I said before, we need another method in case things don't work out so well. So what we're going to do is we're going to use substitution. Now remember what we're doing here. We're trying to find the point of intersection. In other words, we're trying to find where the x and y value that makes this equation works also makes that equation work. So when we're doing that, we're finding the y values and the x values that are exactly the same and work for both equations. Now, with that, what this means is that this y value and this y value are going to have the same value. Additionally, this x value and this x value are going to have the same value because at that point of intersection, they have the exact same x value and the exact same y value. We can use that to our advantage. How do we use that to our advantage? Well, simple. I look at this and I say, okay, this x plus 1 has the same value as this y. We also just got done saying that this y and this y at the point of intersection have the same value. So all I'm going to do is say, okay, if this y is equal to x plus 1 and these two y's are supposed to have the same value at that point of intersection, I can take this x plus 1 and put it in for this y as well. So what that will look like is we will have x plus 1 substituted in for that y and set equal to 2x minus 5. So let's go through that again. That seems to be a little confusing for some students. We're looking for the point of intersection, which means they will have the exact same x and the exact same y value at that point of intersection. Since this y and this y would have the same value, when that y equals x plus 1, this y also could equal x plus 1. Those y's are the same, or at least the point we're looking for they are. So we're going to take that x plus 1 and we're going to put it in for that y. This gives us an equation with one variable. It just has an x in it, and we can solve this. So I'm going to solve this, and you know your equation solving skills. We've got variables on both sides. We choose the side that has the least amount, which in this case is this 1x, and we get rid of it. I'm going to subtract 1x from both sides. When I do that, my 1x minus 1x will cancel out. I'm left with that positive 1. That's going to equal 2x minus 1x, which is just 1x, minus 5. Now it's a two-stepper. We can turn and burn through that. We, of course, get rid of the minus 5. We add 5 to both sides. 1 plus 5, of course, is 6. And that equals 1x. No need to get rid of the 1. We can if we want, but we know x equals 6. Now, of course, we need the point, which means we need the x value and the y value. Well, these two equations, when they have an x value of 6, will give you the same y value. So you can choose one of them, substitute the x back in, and solve for it. That's our second substitution. So I'm going to take the first equation simply because that one looks easier. So I have y equals x plus 1. I'm going to substitute in 6 for x because I know x equals 6. So y will equal 6 plus 1, which gives me a y value of 7. That tells me that these two systems have the intersection of 6, 7. That is their point of intersection. We also can plug those back into both equations, make sure that it makes both of them work, and if it does, we have the right solution. Let's try another one. Let's solve. Oh, this one's one of my favorites. Y equals x and y equals negative 2x plus 3. The process is the same. The problem here is because this one's so simple, it bothers a lot of students. It's actually pretty easy. So again, let's go through the process and understand why we're doing what we're doing. So again, we're looking for the point of intersection, which means that this y value and this y value will have the same exact value. Since this y equals x, that means that this y would also equal that x. So I'm going to take that x, I'm going to put it in for that y. That y, of course, was equal to negative 2x plus 3. And now I have an equation with one variable that I can solve. I'm going to add 2x to both sides. Again, we're choosing the side with the least amount. X plus 2x, please do keep in mind this is 1x. So 1x plus 2x is 3x. Over here, my 2x's eliminate. 3 comes down. Dividing both sides by 3, x will equal 1. So now I know that they intersect when their x values are 1. To find their y values, I will substitute that back into one of those equations. Again, I think the top one's easier, so I'm going to go with that one. So in this case, y equals x. And since x equals 1, y will equal 1. So my solution is that they intersect at the point 1, 1. Simple enough. For some reason, that y equals x, I know there's one on your worksheet that a lot of students get to, and they don't seem to know what to do. That's why I wanted to make sure we did an example. Let's do another. Let's put one with some fractions in it. So we have y equals x plus 8, and y equals negative 1/3 x plus 4. We're going to run into some fractions here. You're probably going to want to use your calculators. The problem with that is I know not all of you have a calculator at home. If you have one on your phone or another one around, you might want to go ahead and pause the video and get that. You also could pull up Desmos on your computer and use that as well. It's just Desmos, type in Desmos Scientific Calculator and it'll pop up. I believe we've used it in class before. So again, we have a system, y equals x plus 8, y equals negative 1/3 x plus 4. We are trying to find the point of intersection, which means at that point of intersection, their y values are the same, their x values are the same. Since their y values are the same, I can simply say, since this y equals x plus 8, this y should also equal x plus 8. So I'm going to take that x plus 8, I'm going to put it in for that y. And that's going to be equal to negative 1/3 x plus 4. Now I have an equation I can solve. So I'm going to go ahead and solve that. Again, variables on both sides, choose the side with the least amount. This guy is a positive 1. So I'm going to go ahead and get rid of the negative 1/3 x by adding 1/3 x. Add 1/3 x. At this point, I look at 1x plus 1/3 x. I know that that's 1 1/3. It's probably easier to work with an improper fraction. So instead of 1 1/3, I'm going to write that as 4/3 x plus 8. On this side, those will cancel out. And we have our 4. I'm now going to subtract 8 from both sides. That's going to give me 4/3 x equals negative 4. Sorry, I'm at the bottom of my board. I'm going to move over here. I have 4/3 x equals negative 4. So I'm going to divide both sides by 4/3. Divide by 4/3. This is going to cancel out, and x is going to equal. If you have your graphing calculator or your scientific calculator with you, or you can pull up Desmos right now, take negative 4, divide by 4/3. We also know that's multiplying by 3/4. So that's going to give me an x value of negative 3. Once I have that x value of negative 3, I can take that, plug it into either one of the equations, and get the correct y value. Again, I'm looking at this and I'm thinking, hey, this top guy looks like the easier one. Let's put that x of negative 3 in for that guy. So y equals x plus 8. We know that x is negative 3, so we're going to put that in there. So y will equal negative 3 plus 8. Y would equal 5. That means that my solution set is the point negative 3, 5. And I'm done. Again, you can verify that by putting that into both equations and make sure that it works. And if it works in both, you are correct. Now I'm going to put one up, and we're going to have you pause the video and have you give it a shot. We have y equals 2 and y equals 1/3 x minus 4. Same process that you did before. Pause the video, give it a try, and after you do it, unpause the video, and we'll do it. Okay? Hopefully you got the right answer. Let's check. So again, I'm looking for the point of intersection. So I'm looking for when their y values and their x values are the same. The nice thing here is we have y equals 2, which might look a little confusing at first, but it's the same process. This y and this 2, of course, are equal. If I'm looking for the point of intersection, I'm looking for when this y and this y have the same value. Same with the x's, but there's no x in that guy. So all I'm going to do is say, okay, well, this y equals 2, and I want these y's to have the same value. That y also equals 2. So I'm going to put 2 in for that y. He's going to equal 1/3 x minus 4. At this point, I'm going to solve that. I'm going to go ahead and add 4 to both sides. I'm going to wind up with 6 equaling 1/3 x. And then to solve, I'm going to divide both sides by 1/3. 6 divided by 1/3, if you want to pause the video and check your calculator or use Desmos. Or we can realize that that's the same thing as multiplying by 3/1. I'm going to get a value of 18. And over here, the 1/3s cancel out. I have x equals 18. Now, the nice thing here is we could go ahead and say, well, I want to find what y is. I'm going to go ahead and plug 18 in. Oh, well, I guess I can only plug it into that equation, and I can solve it. Well, if I do that, I have 1/3. My x value is 18 minus 4. Well, 1/3 times 18 is 6, and 6 minus 4 is 2, which we actually knew from the start. The y value equaled 2. They told us that right from the start. So my solution set is 18, 2. That's the point of intersection. And that's my solution. Hopefully that was enough examples. You're going to go ahead and give your worksheet a shot tomorrow. The key is also available on Canvas, so after you do one, or if you get stuck on one, you can look at the key. If you still have problems or any questions you don't get, don't worry about it. Do what you can. Shoot me an email, let me know which ones you had trouble with, and by Friday, I'm hoping to have a video up that goes over the ones that we had trouble with. Good luck. Talk to you again.